I want to calculate the osmotic pressure in atmospheres of a solution containing 1.50 grams ethylene glycol, which is C2H6O2, in 50.0 milliliters of solution at 25 degrees. Now remember that at 25 degrees, that's really important, so a lot of times I'll say, you can get rid of the extraneous. This time not so much. So what is the formula for osmotic pressure? Well, I have a capital pi sign equals capital M, capital R, capital T. So capital M is molarity, R is a constant, and T is the temperature at the temperature, so at 25 degrees C, in Kelvin. Okay, so let's get started. When in doubt, what do you always do? Well, you always convert to moles. So I'm going to take the ethylene glycol and I'm going to convert it to moles. Remember, you want to look that up on the periodic table to find out how much 1 mole weighs. So when you come back, I want you to pause the video and see if you get the correct answer. So when I looked up ethylene glycol on the periodic table, I came up with 62.10 grams per mole. So I added that into my equation, and as you notice, the grams cancel and we're left with moles. Now you might be wondering, why exactly did she do that again? Remember, we want capital M, which is molarity, which is moles per liter. Well, I've got the moles. Can I get liters? Sure, notice I've got some milliliters. So if you need to write out the actual calculation, please feel free to do that. Some of you may be able to just convert it right away, and that works too. Do what is the easiest for you so that you can get the correct answer. So remember that 50 milliliters is the same thing as 0.0500 liters. So now I've got moles and I've got liters, so that's my molarity. I know what the rate constant is, and I can find the temperature in Kelvin, so I'm going to plug that into my formula. So the osmotic pressure is my moles divided by my liters Now I need to multiply by what? The rate constant, which we need is 0.08206. Now remember, the units are really important, so I've got liters times atmospheres over mole, so moles times Kelvin. Now we said we need the temperature in Kelvin. By this time in Chem 2, you should know that this is room temperature, and so I just add that to 273.15. So just in case you need me to write that down, that's 273.15 plus 25, which will give me this number here, which is 298.15 Kelvin. Now here's where those units are really cool. I'm going to go through and see what I can cancel. I've got kelvins and kelvins. I've got moles and moles. I've got liters and liters. And all that's left is what? Atmospheres. And what did it tell me that it had to be in? Atmospheres. So if you're really careful with your labeling, you can always check ahead of time. Now when I did on the calculator, I got 11.817169. How many significant figures? Well, I'm going to go back to the original problem. I've got 3, 3. Remember, the temperature's not always, so I've got 3. So this is going to be 11.8 atmospheres.